Welcome to Chemistry Lab. Today's lab, the project. Actually, it's today's lab and next week's lab. It's a 2-week project. In week 1, you're going to be given a little baggie with a white powder in it, and the goal for week 1 is to identify the compound. Now, the project lab is a little bit different from other labs that you've done to this point. I mean, typically with your labs, you start at the beginning and you work through to the end. Not so here. For the project lab, you need to read through all of the given information and look for the information that you need. For example, find the experiments within this written material that will allow you to identify the compound. What I mean by that is you need to be able to write the chemical formula for this compound after you've done the experiments. So look for the experiments that are written in this procedure that will allow you to determine what that chemical formula will be. Ultimately, you are identifying the compound in week 1, and then in week 2, you're going to do some experiments with your compound that confirm its identity, and then you're going to write this up in the form of a lab report. If you found this compound in a landfill, what would you recommend doing? So you're going to write about how you identified the compound and the procedure that you used to do that. You're going to look at you're going to describe the experiments that you did to confirm its identity, and then ultimately come up with advice as to what to do with this compound if it's found in a landfill. So back to the compound identification. When you find the experiments in the write-up that allow you to determine the identity of the compound, you will want to be mindful of using controls. Now, your compound is going to be one of a list that we have available in the lab manual. There's, I think, 15 or so different compounds, and your compound's one of those. In the lab, on the day that you do the experiment, all 15 of those compounds labeled will be available for you to use as controls. So, for example, if you're doing a test for example, the nitrate ion, and you do the test on your unknown compound, you may be looking at it thinking, well, is that a positive test? Is that a negative test? I don't really know. What you need to do is use a control, meaning go over to the collection of 15 compounds and look for one of them that has a nitrate and do the test on that compound. So you know for sure that that compound has nitrate in it, and you can compare that result to your unknown. In fact, for all of the experiments that you do in week 1, you really should have 2 test tubes, one with your unknown in it, and the other one with a known compound that contains the ion that you're testing for, so you can compare. You want to take a lot of notes because you're going to be writing a lab report this time. And you need to make sure that both you and your partner have an extensive list of notes. I know from experience it can be rather difficult for people to find the lab partner whenever they leave the lab, but if you make sure that you take good notes while you're there, you'll be ready. So at the end of week 1, you are identifying your compound. While you are still in lab in week 1, I recommend that you plan what you want to do in week 2, so that when you walk into lab in week 2, you are ready to go. So week 2, what you want to do is run experiments to confirm identity of compound. And at least 2 of these experiments need to be quantitative, meaning ones that yield numbers. So the lab manual does have suggestions of several different ones that you can do, several different experiments you can do, but make sure that you plan, like I say at the end of week 1, which experiments you want to do so you can come in week 2 and be ready to go. Sometimes students waste a little too much time at the beginning of week 2 trying to figure out what it is they need to do. So it works more efficiently if you plan ahead of time. So a word about these experiments. I said that at least 2 of them need to be quantitative. For example, if you use solubility as your quantitative experiment, you will be trying to determine how much of your compound is soluble in water, because there's a certain maximum amount of solute you can get to dissolve in water, and after that no more can dissolve. And the amount, the maximum solubility, is variable among compounds. So you can determine that and measure it. But once you measure that amount, you need to make sure that it confirms the identity of your compound. So that means you need to look up the solubility in another source and compare what you measure to what you find in literature. Does it help confirm the identity of your compound? And that's true for any of these experiments that you're doing here in week 2. If you measure a freezing point, for example, what does the number mean? What is the number telling you? Well, you need to look up the freezing point of solution for your compound and see, you need to probably determine the molar mass of your compound and compare that to the molar mass of the compound that is your unknown. Several things to keep in mind. One, there's quite a bit of error when we do this experiment, and that's to be expected, given the fact that we're using LabQuest probes and general chemistry environment to make some of these measurements. So, for example, with the solubility, you might not measure exactly what you find in literature. That's okay. The point is I want you to look at the literature value and compare what you measure. If there is error, that's fine. You can discuss sources of error in your lab report. 2, take good notes. I think I've mentioned this before. If you have your own good set of notes while you're in the lab, it will help tremendously when you sit down to write the lab report. 3rd note, look at the rubric in the lab manual. There is a fairly detailed rubric, and for the most part, this will be how your lab reports are graded. So if you go ahead and look through that rubric and ask questions while you're in lab, that will also save you some time when you sit down to do the lab report. And finally, look to your instructor in class. You're likely to get some additional instruction and additional help in writing this lab report. That's all I can think of for now. I hope you have a great lab.